Spraying WD-40 on electrical connectors doesn't fix corrosion. It creates delayed electrical failures that show up months later in completely different systems. If you've spent almost $1,000 replacing sensors recently and nothing stays fixed, this is definitely why. WD-40 works perfectly on mechanical problems, so spraying it on a corroded connector feels logical, and it does work for about 2 weeks. But here's something you don't see. WD-40 leaves a petroleum film that never fully evaporates. That film then creates an insulating layer between metal contacts. As a result, electrical resistance increases and current doesn't flow properly. And because the contamination migrates along wires through capillary action, failures appear in connections you never touched. In fact, what you're actually doing is starting a 3-stage failure process that's harder to diagnose than the original corrosion. Now, step 1 happens in the first 30 days. This is when WD-40 displaces water from the metal surfaces, making the connection work better than before. If you tested it with a multimeter right after spraying, you would see normal voltage and good conductivity. Now, this is the window where you think the problem is solved, but the countdown to failure has already started. Stage 2 begins between 1 and 3 months later. That petroleum film attracts microscopic dust particles, carbon from exhaust gases, and metal oxides from the air. These then stick to the oily residue and form a thin insulating layer directly on the contact surfaces. What's worse, the film now traps moisture instead of repelling it. This means that you have contaminated oil sitting between metal contacts getting thicker every week. This explains why electrical problems appear in winter or during humid weather, as moisture gets trapped by the petroleum film and accelerates corrosion underneath it. Now, step 3 is complete failure, and it happens anywhere from 3 to 12 months after application. The contamination creates enough electrical resistance that current can't flow properly through the connection. What makes this catastrophic is the fact that WD-40 migrates along wires through capillary action. This simply means that a single spray on a battery terminal contaminates connectors 6 inches away. Eventually, you end up with failures in circuits that you never touched. Alright, let's put all that into perspective by looking at the cost factor. Starting with mass airflow sensor replacement, which could cost you $250. Then there's the oxygen sensor, another $180. Starter relay, $150. $200 for the window switch module. You add diagnostic time at $120 per hour, and you're easily at $1,000 to $1,500, chasing problems that all trace back to a $3 can of WD-40 you sprayed 8 months ago. Alright, let's get to know more about the symptoms, and first up we've got intermittent starting. Now, this is where you turn the key and nothing happens. You give it another crank and the car starts immediately. A week later, same thing. The starter motor's testing fine. The battery's good, but the starter relay contacts are covered in gummy WD-40 residue that blocks current flow randomly based on temperature and vibration and how it feels. Sensor failures are worse because they're harder to trace. When petroleum residue builds up on their connector pins, it creates a voltage drop. The sensor works correctly, but the signal doesn't reach the computer properly. So what happens? You get false trouble codes, you get a rough idle, check engine lights, and poor fuel economy. So you replace the sensor, but 2 months later, the same code reappears. The problem is in the connector behind the sensor, where the WD-40 residue has been accumulating since you cleaned the battery terminals 8 months ago. Another symptom is that accessories fail gradually. Power windows and door locks work in the morning, then stop in the afternoon, but then they work again the next day like magic. So you replace the switch, but the problem doesn't go away. The real issue is in the connector behind the door panel, contaminated by WD-40 that migrated from a different connection. Lighting problems might also show up as flickering or bulbs burning out prematurely. Now, all of these are the results of poor connections that create voltage spikes. And then, battery drain is the final symptom. Here, resistance and contaminated connections forces the alternator to work harder. This means the battery never charges fully. You replace the battery, then the alternator, and the real problem is still there, hidden in a starter relay connector or a ground point somebody sprayed 2 years ago. So, since WD-40 is clearly not a solution, what should you use to avoid such costly failures? Before we get into that, don't forget to like and subscribe. Alright, first, for cleaning corroded connections, you need an actual contact cleaner and not a lubricant. See, these cleaners are specifically formulated to dissolve oxidation and flush out contaminants without leaving any residue. On top of that, they evaporate completely in 30 seconds. The critical difference is what remains after drying. For WD-40, you're going to be left with an oil film, but the contact cleaner leaves nothing but bare metal touching bare metal with no insulating layer. For protecting connections from moisture, you need to use dielectric grease. Now here's the catch here. You gotta understand what it actually does. Dielectric grease is non-conductive, and that means it doesn't improve electrical flow. What it does is it prevents moisture from reaching the metal by sealing around the connection. So, you spread it and apply it around the connection, not on the contact surfaces. If you pack grease onto the pins and sockets, you're insulating them. The grease goes on the rubber boot, the connector housing, and the wire insulation near the plug. See, this creates a moisture barrier without interfering with conductivity. For battery terminals specifically, the process is straightforward. Just clean the corrosion with baking soda, a little bit of water, and scrub with a wire brush until you see bare metal. Then, you rinse thoroughly, you dry completely, and then you apply proper anti-corrosion spray or you install treated felt washers. Here's the thing, proper contact cleaner does cost more than WD-40. About $10 compared to the $3 for WD-40. But you're also comparing that $10 against a $1,000 diagnostic session where the mechanic replaces components trying to find an intermittent problem caused by contaminated connections. Alright, now that you've got the correct products for the job, how do you go about the whole repair process? First, you gotta disconnect the battery's negative terminal first. Separate the connector and inspect both halves for cracks, melted plastic, or corrosion. Now, in the event that there is structural damage, that's going to require replacement, not cleaning. Next, spray both sides with proper contact cleaner. Let it sit for about 10 seconds to dissolve oxidation, then spray again to flush loosened material out. For heavy corrosion, use a brass brush or contact cleaning pin. You need to spray one final time and let it dry completely. Now it ought to dry in about 30 to 60 seconds. Once dry, apply a thin layer of dielectric grease around the rubber seal and on the connector housing exterior. Then reconnect firmly until it locks, and finally, reconnect the battery and test. For sticky switches, spray contact cleaner into the mechanism while working the switch repeatedly. Make sure you let it dry completely before reassembling. For water intrusion, use contact cleaner to displace the water. The cleaner works by mixing with water and carrying it out as it evaporates. You can also use compressed air to blow moisture from crevices. Allow it to dry completely before inspecting it for corrosion, and then seal it with dielectric grease. WD-40 doesn't fail one part, it poisons the system slowly. In the shop, when electrical problems don't make sense, this is one of the first things we look for. So make sure y'all keep it on hinges and bolts and not on circuits. And make sure to subscribe if you want fewer surprises and some smaller repair bills.